Hello, everyone. Thank you for being patient with me and joining the stream today. I am at my dining room slash kitchen table. It seemed like the best place I could actually set up to do this build. As such, our setup might be not optimal. We only have the one camera, but I think we will all have a good time. Can I just get a thumbs up or something in the chat to make sure that you can all hear me okay? Um, again, I moved my podcast microphone from my office to the kitchen. So as a result, I'm just a little worried that something might not work correctly. Um, the goal for today's build, it should be 4 or 5 hours, which is not something I've ever done before. So I'm a little bit nervous. What I have done is I have assembled for myself a Tinybelt beta kit, and what I'm going to attempt to do is turn this into a functional 3D printer by the end of the stream, um, with the exception of things like calibration. But hopefully, we can make something that moves around, heats up, homes, all of that sort of thing. Maybe even print a little cube. Thank you all for verifying that the audio video setup is working as intended. Thank you. I appreciate it. So, we're going to make a functional printer today. We're going to have a lot of fun. I have water and coffee and snacks off screen. So, hopefully, this can be a nonstop build. And again, thank you all for joining me. Let's get this box out of the way. I've assembled a whole bunch of tools, so that seems like a good place to start. For the box of parts edition, as I've been calling it, of the Tiny Belt, I have not been supplying tools, which I know is very common for inexpensive 3D printers. But my logic here was that if someone is requesting the box of parts edition 3D printer from me, that I really hope that they have some tools. Um, from other printers and experience that would help them to assemble it. So, got a whole bunch of tools here. Really, the most important ones that you're going to need are a set of hex keys, and you're also going to need screwdrivers of different sizes. Um, you will also need, hopefully, um, a socket to make your life easier. So this is an 8 millimeter socket, and I 3D printed a little adapter with knurling on the sides. I find that easier to use than just a full socket wrench. I also have these little bins that I 3D printed for putting screws and different parts in there. I find that makes my life easier. And let's go ahead and get started. The way I designed the assembly guide for the Tiny Belt Beta, I like to go usually from the easiest subassemblies to the most difficult subassemblies. No duct tape on board. Fingers crossed I won't need it, but if I do need to, I can run upstairs and grab some. So let's grab some of the parts out of the box to my right. I know the whole drone delivery thing is like sort of controversial, but I sort of can't wait for it to happen. So, according to my assembly guide, something I recommend is people to add the idler mounts. I already did that step. I also two M5 bolts and the T slot nuts to these pieces. There's two of them, one for X, one for Y. So I'll go ahead and add those T slot nuts now. Like I mentioned, I did call this a box of parts edition kit. So it is just that. It's a box of parts. Um, Back in the day when I was shipping out zeros, I would sort them, all the bolts, into the different sub assemblies. It just took so much time. I have since learned that automated bolt counting and sorting machines exist. So if I continue to do this sort of thing, I'm definitely gonna have to get one of those, because it just took forever. And my wife was actually nice enough to help out with that sort of thing. She's much better at it than I am. I can give her a packing list and she will knock it out of the park, whereas I will make mistakes and get tired. So there's that. The entire printer itself is built upon V-slot rails, V-slot nuts that go in there and then get tightened with bolts. So we'll be using tons of those for today's build. I know some people have strong opinions about what a ideal T-slot nut is. So if you have any opinions, feel free to drop them in the chat. I know some people like the slide-in ones, like I'm using here. I know some people like the drop-in ones that you can drop in at any point in the rail, and then when you tighten it, they rotate and catch on to the rail that way. And then some other people prefer, I think they're like spring driven T slot nuts. Hey, Joe, 3D printing professor is here. Amazing. Thanks for joining the stream. Um, so these are our idler pulley mounts. These are all done. Like I said, one for X, one for Y. We'll set those aside for now. The next subassembly that I recommend people working on all depends on the situation. Of course it does. Man, so many technology questions. The answer is always just it depends. At my old job, being a technical resource for selling industrial 3D printers, I would sometimes say that 10 times in a meeting. Well, can it do this? Oh, well, it depends. What printer's best for me? Well, it depends. It's just really funny. So we have some 3D printed M5 spacers, and then we're gonna put bolts with V wheels on the front two mounts and the back two mounts. These back two mounts have eccentric spacers, so those are gonna have to. That's why these holes are larger, and those eccentric spacers are going to allow us to um, tighten the V wheels on the back rail. And because this is a cantilever mount, this is 3mm steel. I don't know if you can see, but I'm just super happy with the smooth powder coating that my supplier does. It just looks awesome compared to some of the inexpensive rough powder coating that I see on a lot of entry-level 3D printers. All of these are secured with a lock nut to try to keep the build a little bit simpler instead of having lock washers and the like. So I'll get these just finger tight, and then I'll tighten them up with a hex key and my socket tool. We are up to 5 concurrent people watching, which I think is pretty incredible considering I'm not a streamer. So good. Thank you all for joining me. Um, if you're not subscribed to my YouTube channel, I would invite you to do that. It's kind of cool that Powerbelt now has more Twitter followers than YouTube subscribers. But I'm not. You can monetize Twitter followers outside of them. There's no ad revenue to be had, at least as far as to do that. And YouTube is telling me that my internet connection is not working great. Looks like we're back. It's a constant challenge to have stable internet. You would think that we would have something better by now. So I'm using my pliers here to tighten this V wheel because based on the sheet metal geometry, my socket tool doesn't really fit in there. If you were using a standard socket wrench, it would probably work just fine. Okay. Thanks for the feedback, Chris. I can tolerate a slight interruption without beating myself up too much. These are our eccentric spacers. I'm hoping that everybody on the stream knows what those are. Um, I didn't know what those were for the longest time. Um, Eventually figured out what they're useful for. So we've got a bunch of different spacers. We have 3 millimeter high, 4 millimeter high, and 5 millimeter high printed spacers. So for the eccentric wheels, we want 4 millimeter spacers. So the easiest way for me to do this is just to throw them all onto the table and then look at which ones are the tallest and which ones are the shortest, and which ones are in between. So this looks like a 4 millimeter, and this looks like a 4 millimeter. It's important to make sure you have the right ones, otherwise the V wheels on the front and the back won't line up, causing all sorts of problems. There's a tiny washer inside these V wheels that sometimes gets misaligned, and then I have to go in with a thin tool like the screwdriver just to get it back to center. I'm second guessing my spacer choice, but I think once I tighten it up, it'll tell us for sure if I picked the right height. That's looking pretty good to me. So on all these eccentric spacers, there's a notch, um, which tells you the direction that the offset hole is. And I recommend that the notches face this direction or this direction. Essentially, that will make it so that the wheel is in alignment with where the holes are cut on this sheet metal mount. So that'll be a neutral starting point, and then we can, if our notches are all facing This way, we can turn them closer to the inside where the linear rail, the V slot extrusion will be, to tighten it, or we can turn it away to loosen its grip on the rail. In testing, I've found that I have to tighten these quite a bit because we are using a cantilever design, but that's just a lot of trial and error. So these are tightened to the point where the wheels can still spin. I like to test these, and I also test the wobble. I guess that's not a technical term, but essentially I'll see if this is tight enough where it doesn't move back and forth, and it's actually just in alignment in the hole the way it is intended to be. All of these are looking good, and again, I will just use pliers to move the notch where I want it to be. So this rides on the back rail of the printer to make up our x-axis. I'm not sure I actually introduced this this sub-assembly that way, but now I did. This spot right here is where our y-axis V-slot mount rail will go. So I will just prep these bolts and T-slot nuts so that they have a place for when we install the arm later on. The last thing we'll want to do is attach the y-axis motor to this mount. So I'm going to grab that out of the box. These are NEMA 17 motors. No surprise there for everyone that's super familiar with printing. And then I need to find some M3 by 8 millimeter long screws. I didn't want to get these confused with M3 by 10s, which are also in the kit. So I put them in a separate baggie just for me. For everyone watching, what is your opinion on Phillips head, flathead versus hex socket screws? Some of the beta testers uh, gave feedback of they wanted all hex screws. Um, and I just couldn't figure out why. I find Phillips heads so much easier to use. Um, I don't have to find a dedicated um, hex key for every different size. Like one Phillips screwdriver can fit a lot of different M3 screw sizes. Question comes up, include spare screws and that sort of thing in a separate bag. Yes, that is certainly the goal. Um, this is our completed x-axis carriage. We will need to put a pulley on this motor, so let's just do that now. I don't think I've been called captain before. This is a first. Didn't see that coming today. Um, so with the beta kits, I didn't include any extra parts, which was a suggestion that people immediately uh, gave. Was having one extra of every component would be super nice in case you drop one or your cat steals it. I know I have that problem from time to time. Um, so here's our completed X carriage. Again, we'll set this aside. over here for now, and we'll move on to the next one, which is definitely one of the more complex sub-assemblies. So this will be fun. So this is our hot end carriage. Again, I have been batching some of the sub-assemblies, so doing them all at one time at the office. I'm not streaming from the office because I don't have internet there yet, and I don't really want to pay for it, um, considering I have internet at home, which is fine for doing Zoom meetings and that sort of thing. So all we did here was I've been batching hot end assemblies. That's where I was going with this. So this was already made by me. I didn't want to disassemble it because that's just be wasting time. So here we have the wheels. These two are static. This one has the eccentric spacer, so we can tighten and loosen it to our intended tightness. And this is a 3D printed spacer that gets attached to the sheet metal mount with two screws on the back of the sheet metal. Those are through holes and then they thread into this. Feedback from beta testers suggested heat set inserts or square nuts, something like that. Definitely on the list for improvements going forward. If not, I found aluminum or brass standoffs. So it's essentially a really long hex nut that I think will be even better and more rigid uh, without the need for any heat set inserts for this part. But this is where the hot end attaches to. So I'll find the hot end and let's do that now. The current spreadsheet says that this kit will be offered in a few different tiers at the launch. The first one I'm calling the Maker Edition of the Tiny Belt. And the requirement there is that it will come with all of the parts that you need except for the 3D printed parts. Um, Feedback from beta testers was that this is a difficult build. Some of that is certainly due to my ability to make a uh, assembly guide that is as thorough as someone other than me needs to correctly assemble this. Um, but we have some very smart Voron builders in our beta testing group, and they struggled with it. Um, so they pretty quickly recommended not to offer um, a self assembly kit. Um, but I really want to be able to offer this at a very affordable price point. So I think with kind of that barrier to entry for people to have the requirement to print their own parts will kind of weed out some inexperienced people that would really struggle with the build. That way, people only who already have a printer would be encouraged to buy that tier. The majority of the printers that I expect to ship after the launch will come at 90% assembled, so that you will only have to, in theory, bolt on the Y-axis arm and maybe the LCD screen before you get up and running. That will eliminate a lot of the more challenging aspects of the build, especially attaching and tensioning the conveyor belt. Um, so that's where my head's at today. Anything can change, but that's where we're at. Let me grab the hot end and we will put this on there. Not might not be a bad idea to include the pulley at the correct height. Not a bad idea. Hopefully with most of them being 90% assembled, that won't be an issue. True Tech, I think it's really funny that you came up with that idea. I was at EarF in 2019. It seems like ages ago. Um, but they came up with that same idea. Some people were like, "Oh, I want to print benchies one after another on a conveyor belt, drop them directly into a grinder, drop the grindings, the granules directly into like a Phillips that turns it into filament that feeds it back into the printer on an infinite loop, and then just like laugh as the quality of the filament and therefore the benchies gets worse and worse over time." Um, so it's so funny that two people years apart came up with that same idea. Here is our hot end. Now, this is um, a very standard Creality style hot end. Certainly controversial choice in 3D printing circles, but again, the goal of this project is to create the Ender 3 of belt printers. And starting with this hot end um, is a great way that we can accomplish that. And then there's so many off the shelf upgrades that people can pick from, whether it's Micro Swiss or E3D or Slice, any of those things. I just want to give people a starting point to get involved with belt printing. One thing that I don't like with how these are shipped is that the Bowden tube is coiled up really, really tightly. Uh, but that's probably to save cost in shipping and volume and all that. So I like to stretch it out less coiled. That'll help when we have to route this Bowden tube later. Um, One thing that we are going to have to do, maybe I'll just do it now, take off the silicone sock. These ship standard with a Mark 10 style nozzle. A lot of people probably never pay attention to the difference between a Mark 10 or 8 style nozzle. The Mark 8 style nozzle, if I remember my history correctly, um, MakerBot replicators, and they tend. There's no way you can see this. This isn't going to focus. Um, they have a pretty sharp angle on the tip of these nozzles, whereas the Mark 10 have a less sharpness to it, and that is going to be important when you're printing at an angle. So we're going to need a Mark 8 style nozzle to be able to print at an angle without the nozzle running into our conveyor belt. So while we're here, and because this is cold and hasn't been hot tightened to my knowledge, and they have these screws on the sides that allow you to uh, have less troubles, we'll just pop that nozzle out. We'll put in our Mark 8. Another reason why I wanted to, I guess, choose this hot end is that it's so standard that you can find Mark 8 style nozzles in brass, in uh, um, tool steel, in stainless steel. You can find them in point 0.2 and point 0.4 and point 0.8, all the different sizes. So designing off of a set of standard parts allows people to customize their machines so much easier. And I think for a hobby level printer, that's absolutely what I'm looking for. Um, Looking at some of the recent announcements from Prusa and from E3D, I know that they are, yeah, kind of started as maker companies, but as the industry matures, it seems to me like they're doing more and more stuff that is developed internally, super custom to their machines, um, and incompatible with off the shelf parts, um, which I'm sure they have reasons for that, and it works well because they have huge R&D teams at this point. Um, but when it's incompatible with other parts, it limits options for the consumer. And then as I've contemplated these things, in my opinion, it kind of decreases the value of it even being open source if it is open source. Particularly, I'm thinking of the Prusa XL. Like, if uh, if they open source their zero backlash cycloidal drive extruder, it's so complicated that who's really going to be motivated to clone it or copy it? I think now I'm just rambling here, but I believe Elon Musk patented a whole bunch of stuff for Tesla and then said, "Hey, we patented it so that we could prove that we own it." But the patents are open source if anyone else wants to take advantage of them to build electric cars. Um, but again, it's so complicated that the barrier to entry to clone a Tesla, um, it's difficult. This is me stopping myself from rambling about patents and open source and all that other stuff. But it's an interesting topic. So these are M3 screws that go right through the hot end into this printed spacer. Next, we are going to find our cooling fan, our part cooling fan, our heatsink cooling fan, and our cooling fan mount in the box and attach it to this assembly. Here we go. Fans. We have our mount. Put the sock back on. One thing that I missed is that we need to put some bolts in here that will attach to our GT2 motion belts later on. This is one of the very few places where you have standard M5 nuts instead of M5 lock nuts because they're not necessary, and tightening a lock nut all the way down this would be pretty irritating in my experience. So these are M5 by 30 millimeter long bolts. Mad Monkey has joined us. It's crazy to me how I can like meet people on Twitter and then have like recurring interactions with them as if I know them in real life. Scara dual arm for a belt printer is a very interesting idea. And actually, in one of my notebooks, there's a sketch of one. But this was going to be a much simpler setup and less burden on the control board to calculate all those motions. But I am super fascinated by Scara type printers. On paper, it seems like they should be super affordable to be able to make. But for whatever reason, they haven't really caught on outside of, I think, large robot arms, large printers, that sort of thing. With the exception of Plybot, if anyone's familiar with that. Really curious how they're doing. Is there a way you can chat with me outside of Twitter and YouTube? Sure, there's a contact form on the homepage of the website, powerbelt3d.com. You can shoot me a message on there. I think it's at the bottom of the homepage. I check email every day, maybe every other day. I don't get a lot of email. As funny as that is, I get way more Twitter interaction, so that's where I tend to spend most of my time. This is our Heatsink Cooling Fan, the good old 1040, 10 millimeters thick, 40 by 40 millimeter fan. And this goes cage side facing the heatsink. This is one of those little points that I thought everybody would know that they didn't. And then some of the beta testers were like, I'm getting tons of heat creep. I'm like, your fan's backwards. This whole thing has been such a learning experience for me of like what other people know, what other people understand, how much detail they need in explanations. It's interesting. Now that we have a few more people joining the stream, Phillips head screws or socket head screws. One of the beta testers, well, a couple of them actually, was like, I hate Phillips head. I want everything to be hex socket screws. So what I'm doing here is I'm sorting through all these parts for the M3 by 12 millimeter screws. which look very similar to the M3 by 10 millimeter screws, but we need the 12s to go through the fan and thread into the 3D printed part. Hex screws. All right. Here I thought they were just being very particular, but maybe there's some merit to it. I always like to ask multiple people for their opinions before making design changes like this, because sometimes people just have very strong opinions, but they're the only ones. Okay, maybe the M3 by 12 millimeter screw will show up. Maybe not. If not, I think having 3 screws on this fan will do just fine. Oh, there it is. If you see the light changing on the table, my cat Mia, who keeps me company and is our director of quality appearance, is playing in the blinds. There are chipmunks that live on our back patio, um, which taunt her every day. It's really a sad situation. Here's our cooling fan, 4010. Then we're looking for M2 by 5 millimeter long screws. Again, these thread right into 3D printed part. If and when I I launched the Maker Edition Tinybelt as a reward tier, I'm definitely gonna have to sort these bolts for people, as much as it takes time. Um, because sorting through all these parts and looking for these teeny tiny M2 screws is pretty inconvenient. All of the printed parts are made in PETG. I for a while was like, oh, I should do everything in carbon fiber, or I should do everything in polycarbonate. It'd be a fun excuse to upgrade a couple of my machines to be able to print polycarbonate. Um, and then the more I thought about it, I was like, if Prusa can make everything in PETG and still be Prusa, it's probably just fine. So now to attach our fan mount to the sheet metal, what we're going to do is we're going to grab 2 M3 by 10 millimeter screws, and we're going to grab 2 M3 nuts. So in order to try to save some cost, I didn't have our sheet metal supplier thread these sheet metal parts. What I did was I just made through holes, and so these bolts will go through the printed part, through the sheet metal, and then secured on the back with an M3 bolt. If you didn't know, every time you add a hole to something, or if you add a thread to something, the cost goes up. And in an effort to make the world's most accessible conveyor belt 3D printer, I opted for through holes. Click together fasteners without screws. I think those are called Legos. Chris, I have Velcro fasteners. That's interesting. Chris, my sheet metal supplier is fantastic. I would be so happy to refer them to you. some of my suppliers in the Far East uh, are great. Some of them are okay, and some of them take 5 days to get back to me. Um, my sheet metal supplier is one of the good ones. Um, they will build anything to spec that you want, any surface finish. Um, they send me an email wishing me to have a good weekend. They send me emails wishing me happy Columbus Day, which is such a minor holiday and also controversial uh, these days. Um, and I'm like, man, you guys are really on top of it if you're going out of your way to wish me happy Columbus Day. It's not like Christmas or anything. Um, but they do a great job, and they have a pretty fast turnaround time. One of my biggest struggles was that a lot of American sheet metal shops never got back to me. Just too small of volume uh, to be worth their time, I guess. A lot of times, the ones that did get back to me um, peppered me with questions about what what material do you need? What tolerances do you need? What is the RA value of the surface finish that you need? And I'm like, guys, I sent you step files. Just cut the step files and bend them, and it'll probably be fine. It's just a prototype. Um, Asking questions like that is good. They're just doing their jobs. But a little frustrating on my end. We have Info Mario Ruiz. I'm gonna pronounce that horribly. Um, from Spain joining us. This is now an international 3D printer live stream. Never thought that would happen. Um, so this is our completed, but not wire wrapped hot end assembly. So we got everything where it needs to be. Again, we will set this aside for now and come back to it later. We'll put that right there. So that's actually our most complicated sub-assembly. The next one is our X-axis motor, which goes here, and our extruder motor that goes here. So I'm gonna have to find those parts. Bear with me. And I misspoke. We have to put our cooling fan shroud on here. Um, some of the beta testers were like, the cooling fan shroud should be better, more directed at the nozzle. And my response was, makers love making cooling fan shrouds. I swear I could probably do a flow simulation and prove beyond the shadow of a doubt that I have fully optimized the cooling flow air path. Um, and someone out there would still be like, I wanted to make my own. So, and this one looks like a snake. And, I kind of love that. Um, so as a result, I wanted to keep the cooling fan shroud super simple because here's a close up if it'll focus. Um, Wanted to keep the cooling shroud super simple. I'll probably improve it and change it over time, but for now, it's simple. Now we'll set this aside, and I will grab our extruder. Got a couple motors already, and we'll put this together. I don't know if I'm comfortable being on a 55-inch screen, but whatever Whatever makes you happy. So this is a dual gear extruder. This is a super common upgrade for the Ender 3 or the CR10 or the artillery whatsoever. Every printer kind of in that class as a simple Bowden dual gear extruder. I'm also pretty confident that this is the exact same one that the Creality CR30 uses. People seemed happy with that. So, what's crazy though is that when I look online for lots of common extruder upgrades, there are like no instructions on how to actually put them together. So I filmed a short video just focusing on the extruder assembly. I haven't edited it yet, but it's on my to-do list. Gonna grab our NEMA 17 wire. I'm gonna put our x-axis on first, just to get that done. Exactly. Looking at the chat, there's so many different cooling fans, all for the same hot end. Sometimes for the exact same printer. It's nuts. Everyone's got their preferences and what makes them happy. So, thus, decided to keep it simple. You could definitely print a ukulele. A full-size guitar would be a little tough. But one thing that I was considering during all the design and prototyping phases was making a design that's scalable. Um, that way, you could make an extra tiny belt or an extra large tiny belt in the future, because that seems really cool. Something about me is that I have no musical talent whatsoever. It's really sad. Just gonna clear out this hole a little bit. When I'm packing parts, if a part is like a little warped or something, where I don't think anyone other than me should have it, I give myself the lower quality printed parts because it won't bother me if it's a little warped. All right. X motor is attached. I'm gonna clean up this hole a little bit. Here I am just jamming side cutters into this hole like a madman. Okay, got our next motor. I'll line that up. First thing we're going to do is we're going to put our back plate on. And in this kit, there is one screw. I mixed up all my screws. It's going to be a disaster. There it is. There's one screw with a chamfered head on it instead of what I think is a button head, the rounded tops. So this is the one that we're going to need to go into this hole. That way the arm of the extruder can move freely. Before I get too far, One thing that I've screwed up in the past is if you fully tighten all three of these mounting screws, the this spiky part won't allow you to put the drive gear onto the motor. So before I get all of this tightened up, let's put this in place. This might be the one complaint I have about this style of extruder so far, is that it only has one tiny grub screw to be able to tighten it onto the motor. So it's important to make sure that that is on the flat of the motor shaft. And when I'm looking at this, I'm trying to make sure the teeth. There's probably. This is so frustrating. I really need a second camera. The teeth of the gear line up with the filament outlet of the extruder mount. $400 parts. That reminded me of the 3D printed Ferrari project. God, it's probably 2 years old at this point. We think some alignment problems with the holes in the motor and all that, so I'm just going to take a step back for a second. Looks like giving myself a warped part is coming back to bite me, but this is a Tinybelt that I'm keeping to be able to produce parts after the launch, so I can reprint this part later, but for the sake of the build, I'll just trim this. And hopefully that will sort everything out for mounting the motor. That's looking much better. Precious Plastic is a very cool project. Very involved, very encouraging of people to use what they have available. It's cool stuff. I once did an independent study in school, um, specifically focusing on turning old 3D prints into new filament. It went okay. Um, yes, Chris, it was my plan to call it the Tinybelt and also make it bigger than anything else available in the hobby space. At least I'm pretty sure Black Belt's still bigger. Um, I like the irony. I like the irony. Um, the other thing was that it takes up less desk space than the Zero does. So it is tiny in a way compared to the last printer that I was shipping. Danny, I am launching the Tinybelt on Kickstarter. God, as soon as I can get all these beta printers out the door. It's been a moving target as to when the launch will actually be. At this point, I think the best option is to wait till January, which kind of sucks. I would have liked to go to market faster, but it takes time to do things correctly. You can absolutely mount belt printers on your wall. I designed a wall mount for the Tinybelt. All the parts are printed. It's 3 printed parts. But I'm a little scared to actually put it on my wall. I'm worried that once I mount it to the wall, it will be super noisy because if it's attached to the wall but it's not acoustically isolated, wow, I sound so smart right now. I know nothing about acoustics. I'm worried that its vibrations will be amplified by the wall. It'll cause the wall to resonate with it, and then it'll just be too loud. So I don't want to do that. It makes me nervous. I'll try it. I'll try it at some point. Here's our extruder spring. Now we have a long M3 bolt. We've got this spacer in there. Next thing we're going to have to do, there's an M3 bolt that we're going to put into this threaded section of the lever. Excuse me. One thing I've noticed from assembling a whole bunch of these little lever arms is that sometimes the threads on the inside of these are a little rough, and I've needed to take pliers or something to tighten them fully, but this one seems okay. This goes in here. One important point is there's this little brass collar that goes over the M4 screw of the extruder, and then it's so important to have that. The spring will rest on it. That way you can actually adjust the tension of your extruder. So the spring is going to go around this M3 bolt, and it's going to rest on this collar. Now this part is a little tricky because you have to compress the spring, get the screw to align in the hole, and then tighten everything down. I told you this is tricky. I'm going to loosen this screw just to make sure the spring is as loose as possible. Trying to get all this to align. Okay, I'm going to pull this extruder arm off and try again. And we have passed the first hour of the stream. Congratulations, and thank you to everyone that has been with us the entire time. I know some people who live streaming is totally their thing. This is only the second time that I've done one. I did one yesterday afternoon to practice and make sure all the cameras and everything were working. And this is the unfortunate step where I realize that I put the extruder on at the wrong angle. So let's back up a couple steps. Hello, Edge of Tech. Thanks for stopping by. Danny, you are dedicated. I admire that. Hopefully watching me struggling with this extruder is super entertaining. Like I mentioned, this is a very tough step. You gotta compress the spring. It's a very stiff spring. I think the M3 screw that's supposed to thread through the aluminum back plate and into the motor, the teeth are digging into the aluminum. So I can't actually get it off of there. Let's take this screw out. There we go. Okay, like I mentioned, I have this extruder facing the wrong angle. The output should be this direction, not this direction. So, we're now up to 8 people watching the stream. YouTube will tell me after the fact, but I'm pretty sure that is our highest number yet. Thank you all for joining. Old school Saturday Night Live. I still watch Saturday Night Live. Not on Saturday night though. It's on way too late for me. But usually my wife and I will watch it Sunday nights. It's a nice breakup from whatever series we're working on at the time. Okay, now it's at the correct angle. Installing this extruder is a lot like changing a tire. You can't tighten one screw all the way. Otherwise, it can cause some of the other ones to not align correctly. So, tighten them alternating. All right, I think we're finally there, you guys. Holes aligning where they're supposed to. I can just tighten up these screws. I'm seeing in the chat talking about how great makers are. Really, I couldn't agree more. I've always been a maker, I guess. Building stuff, taking it apart. I wrote and talked about my projects on Instructables for a long time in junior high and high school. in my opinion, it's so much more inspiring doing a lot with a little bit. Taking a $30 of plumbing parts from Home Depot and making a potato launcher, or similar in a similar spirit, taking off the shelf parts and making something that performs really well for not a ton of money is much more inspiring than you know a large company making a small iteration on stuff that they've already done and been working on for years and acting like it's a grand revelation. That's really been part of my goal with Powerbelt from the beginning, is to empower uh, the little guy, if you will. People that might not have $100,000 to spend on a 3D printer, or might not have $20,000 to spend on a black belt conveyor belt 3D printer, but still have ideas that they want to make, or businesses that they want to start, and they can't get there with if the barrier to entry is 5 figures. So this is our X motor. This is our extruder motor. I'm liking how this is coming together, despite the speed bumps. I'll put a little bit of tension on that screw, and we'll get a GT2 pulley on this motor. I think that once automated 3D printers can be more widely spread, more affordable, we can create somewhat of a manufacturing revolution where people can make the parts that they need where they need them. And when you look at some open source filament makers, I think that's when things get really exciting. Um, People across the world, once the Tinybelt becomes open source, will be able to source things locally, or source off the shelf parts uh, from China. China, being the global manufacturing leader, has the ability to ship parts all over the world. And again, I designed this around standard parts, so there's nothing unique or proprietary here. It's built upon the foundation of open source 3D printers, so that people can build these and then use these machines to build parts for people. Um, this is our completed sub assembly. One important thing to note: there's this little blue clip that goes on the fittings specifically for the hot end. So I don't want to lose this. I'm just going to put it here for the time being, and we'll put it on the hot end later. Now I think we're at the point where I can transition over to working on the frame. So this is going to require a little bit more table space than I have right now, and I'm gonna get some more coffee. So if you need a break, now's a good time to do that while I get a little bit reorganized. Woo, we're up to 10 concurrent viewers. Thanks for joining us. My coffee is heating up. Um, if you're watching, feel free to chime in on the chat. Coffee, tea, or energy drinks. So now we have our frame itself. So this is the back. And if you're looking at the machine from the front side, the right and the left side. Um, so now we're going to start attaching stuff to the frame, starting with the rear roller mounts. So this is one of them. And this is the other. So this goes on the left side, this goes on the right side. These don't match because of a issue that came up uh, with the heat beds. So they came in larger than expected, which has created a ton of different challenges. And this is the workaround that I came up with, was changing the heat bed mounts a little bit, which is super nice that I used 3D printed parts for these, not sheet metal. Otherwise, it would have been way more difficult to kind of pivot the design when some parts came in larger than expected. Maker Viking has joined us. Hello. Thanks for stopping by. I'm going to tighten these rear roller mounts just a little bit. I misplaced the hex key. It matches these screws. I've got this one as a spare. All right, having these screws here is starting to bug me, so let's move these off to the side. Again, M5 screws. These actually are hex screws that go through the printed part and with a T-slot nut on the end. That way we can slide this onto the frame. Closed loop steppers or servos are such a cool idea. I kind of wish more people, more companies picked them. But I don't think they're right for the Tinybelt. The Tinybelt's goal is to become the Ender 3 of conveyor belt 3D printers, something that's minimalistic and affordable to get people's foot in the door. Maybe on a future belt printer that costs 10 grand. And I can hire a software engineer. These are rollers, 8 millimeters in diameter. Again, some of the heat bed size really threw me for a loop in trying to work around that. This roller is a little shorter than it would be ideally, but it does reach from bearing to bearing. Now I'll tighten these up. I'll probably have to loosen them and adjust them at some point during the build, but I'll stick with those for now. Next, we're going to put the heat bed mounts onto the frame. So we've got 4 of those, one for each leveling point. Not totally sure where the chat is directed, but I didn't actually invent the belt printer concept. The angled axis conveyor belt 3D printer, to my knowledge at least, was invented by a guy named Andreas Bastian. He initially created the concept in an effort to 3D print textiles or fabrics, if you prefer. And he published the concept as open source as early as 2013, I believe. He called it the Loom printer, spelled L-U-M. So you can look that up if you'd like. It's both on his website. I think it's on the RepRap forum, and I believe it's also on Instructables. I want these rear roller mounts to be very close to the rear roller so that the heat bed will butt very close to the rear roller so that our hot end can touch the heat bed. Kickstarter launch price will be starting under $400. I'm still working on the specifics on pricing and different tier levels. I believe the under $400 option will be, yes, Mad Monkey coffee right here. It's needed. The under $400 option will be the Kickstarter exclusive Maker Edition of the Tinybelt. So the idea for the Maker Edition is to give a kit with all the parts that you need, except for the 3D printed parts. So you would get sent the files, print the parts, and build your Tinybelt from there. Right now, that option in my spreadsheet, under 400. And then other reward tiers are between $400 and $500. All reward tiers, even one that I have in mind with a couple upgrades, are under 600. So my whole goal is to be affordable. Um, when you look at what else is available on the market from Creality or from SaneSmart, I believe those are the only two other uh, entry-level belt printers competitors. Uh, Entry-level belt printer competitors at this point. Um, both of those are around 1,000. Um, so particularly if you are in the Western world, getting a printer for call it 450, $500, um, and then paying for 20 to 30 bucks of shipping after the campaign, still a lot more accessible than $1,000. It's really bugging me that I misplaced my hex key. Hopefully it turns up, because this is the most common size for this build. I put these M5 screws on backwards. This is the right way to do it so that you can slide them into the V-slot extrusion. I haven't used an iFactory. So it's really hard to comment on what I think about them. I did leave them out of the affordable options, so apologize. I guess they do have a reasonably priced belt printer. I think people having options for affordable belt printers is awesome, and so I'm in support of iFactory, I suppose. But having not used one, don't have any strong opinions. I've talked to a couple people who have used them. They say they're fine. I think there's pros and cons to every single product, right? No matter how popular it is, there will be some people that say it's not for them. I think smartphones are probably the easiest target for that. Um, I've never been an iPhone person. Here's that hex key. Oh boy. I'm not going to want to put this on. I'm going to want to put the control board case in first. There we go. Control board case. So I'm going to grab the control board. We can mount that in there, and then we can put the case in. The control board is an SKR Mini. I have been pretty happy with the quality of Big Tree Tech control boards. They all come with these little squeaky rubber ducks. I think I'd rather save $1 and not have them put them in there, but that's how they do things. So we're gonna need M3 by 5mm screws, and we're gonna use 3 of them to attach the board to the case. And this is another one of those situations where you're going to want to put the screws in, these thread right into the case. You're going to want to not fully tighten all the screws to avoid any of them causing misalignment challenges. So tighten them a little bit, then go around and tighten them all the way. We'll put our heat sinks on. Up to 11 people watching at the same time. I'm going to keep shouting it out anytime I see a viewer increase. I said it before a couple times during the stream, but it's pretty incredible to me that you all showed up to watch this build, considering I'm not usually a streamer. While you're here, I don't typically watch a lot of live stream content. Usually I'll watch it after it's live. But if you have any 3D printing or tech related people that you follow that do a lot of live streams, feel free to recommend them to me in the chat. I feel like the live format is really interesting because you can interact in a much more powerful way than just posting static videos and content. So I'm pressing down on all of these heat sinks to make sure that the adhesive really sticks. A lot of times these adhesives are pressure sensitive. So I want to make sure that those heat sinks are really on there. Nero 3DP is one that I'm familiar with, actually. Haven't watched anything live from him for a while. I didn't realize he did it every Saturday. Having a live co-host would be awesome. Maybe if I do more of these, I will have to sync calendars with people. Fire up StreamYard and then like bring in different guests throughout the stream. That would be cool. So we're M5 bolts, T-slot nuts. Now we're ready to slide this in. Initially, I recommended people slide it in face up, but our heat bed is going to have to go on top of this. So beta tester feedback suggested that we mount this upside down, which I've done on a couple builds for the 90% assembled versions of these printers. So I'm going to do it that way. It makes wiring and making changes to the wiring much easier. So we're going to slide this on the top rail here, and we'll tighten that up. My workshop also looks like crap right now. And to be honest, it normally does. And I kind of like it that way. I think a messy workshop is a sign that stuff actually gets done in there. Anytime I walk into a maker space and it's clean, I'm like, no one actually uses this. Control board's in place. Now we can slide our fourth and final heat bed mount. Man, 1 million views by Friday. That would be awesome. Okay, we've got our heat bed in place. We've got our heat bed mounts in place. We've got our control board in place. One thing that I think I forgot was our power supply. So that'll be a good thing to do next. The power supply goes right here. So let me grab that and we'll get that installed. So this is our power outlet. We've got a power supply mount. We've got our power supply cover. I am out of coffee, so be back in 2 minutes. Not to have coffee to try to keep the energy up on the stream. The weather where I am is not doing me any favors. It is gray and rainy and just so sad out there. So this is our outlet. It fits into our 3D printed mount. And gets secured with some M3 screws. For people paying close attention, this might look a little strange. The holes in this particular printed power supply mount, the mounting holes are a little not where they should be. Again, when I screw up parts, once I realize I screw them up, I will keep the flawed parts and ship out the nicer ones to beta testers in this case. But I'll just kind of force these screws in there, and we'll be fine. Oh, thanks for sharing, Danny. Facebook groups are such, in the 3D printing world at least, so interesting to me. I used to share to Facebook groups our Power Belt posts all the time, but Then I stopped because the people that I meet on Twitter and LinkedIn, God, they're just a lot nicer most of the time. I feel like so many people just go to Facebook to complain. I appreciate you sharing nonetheless. If we can get some more viewers out here, that would be sweet. All right, so I had to switch screwdrivers. Um, interesting. One word for it. But we've got our power socket on there. The other thing that we're gonna need is our 12 volts power cable. So let me grab that from our box. I'm gonna need to strip these wires. Okay. Feedback from beta testers has, I think, not surprisingly, recommended having uh, actual crimped terminals on all the cables. Not being an electrical engineer, that's one of my blind spots as far as figuring out what the appropriate connector in every application is. Um, but between now and the actual launch, that is homework that I will have to do, or consultation that I will have to get to make sure that our electrical cables are safe. At least I didn't make the grave mistake of tinning any of the wire connectors. Am I right? Uh, from what I've gathered through a small amount of research, just having raw copper wire is acceptable in most cases when attaching to a screw terminal. You know, you're right. Sunday morning is probably an odd choice. It's not a Friday night or a Saturday night for a 3D printer build live stream, but it worked for my schedule, which meant, in my opinion, that is the perfect time. Also, my wife doesn't always work on Sundays, but this is one that she had to take a shift, so super convenient for me to take over the dining room and build a 3D printer. So, all right, so we're gonna have to attach our power outlets, hot, neutral, and ground to our power supply, and then we can also attach our uh, 12-volt power cable. 6 p.m. Huh. Time zones are so crazy. All right, looking at the labels on the power supply, the live is to be all the way to the right. Neutral is next to it. ground. And it's looking like we need negative on the right, positive on the left. I'm going to loosen up these screw terminals a little bit more. And we're up to 12 concurrent viewers. Danny, I'm going to give you credit for that 12th viewer. Probably a Facebook person. If you've joined the stream and you haven't said hello in the chat yet, I'd invite you to do that. You can connect with all the other wonderful people on the stream. I believe I want this oriented this direction. Just going to feed the 12-volt wire through the hole in the power supply cover, and then we're going to need to grab our M4 screws to attach the case to the actual power supply. These are the only M4 screws in the entire build. It's very strange to me how they use M4 screws, but so many other places in electronics, it's always M3s. Edge of 3D, you've been with us for almost 2 hours. Thanks for joining. I estimated this would be a 4 or 5 hour build in total. So I think we're moving along at a pretty decent pace. Man, I love building stuff. I've never been very good at video games. So I had to find something else that was a fun hobby. And I always grew up playing with Legos, like I said, building stuff, taking apart calculators and remote controls and all sorts of stuff. I made hydrogen generators when I was in junior high and high school. It was always just more fun to me. It felt more meaningful than playing video games. Not that there's anything wrong with that, but again, I was just never good at it. It's sort of ironic. I was always fine with 2D video games. You can think like Super Mario on the Game Boy Advanced or The Legend of Zelda. I love my Game Boy Advanced. Because it was all two-dimensional. Something about either being in a first-person or a third-person 3D world just was so hard for me to do. But it's funny because now, in some ways, I operate in a 3D world doing CAD modeling all the time. But I can operate there just fine. I think it's because nobody's shooting at me. And I can rotate around the model and do what I gotta do. So there is a mount built into the power supply cover that attaches to the frame. And there's a separate one that threads into the back there. So we can put on our M5 bolts and our T-slot nuts, and then we can slide this onto the frame. This is a good point to check what the switching power supply voltage is set at. This is super important. You want to make sure it is set 220, or in my case, 120 volts, according to where you are at in the world. I think part of the reason these types of power supplies are so popular is because if you are sourcing parts, you can source the same exact power supply for most of the world, or North America. um, and then people can just kind of select what they need from it. You don't have to have an EU power supply and a North America power supply. Same power supply, just different power cables. Makes life much easier. And I'm lifting up the frame here just to tighten the screws that attach the power supply to the frame. Modeling a screen for the tool changer. I assume that's the E3D tool changer, and not, well, it can't be. It's a Prusa tool changer. Those aren't shipping for another year. Okay, got our power supply on, got our heat bed mounts on. I believe that's everything we need. Next is going to be our front roller mounts. Tool changing is such a cool concept. I'm really happy that E3D kind of took more awareness to it, and then even with their Revo, they're making manual, non-automated tool changes, nozzle changes, much easier. One of the things that I've learned ever since kind of starting on this belt printing journey is that a 0.4 millimeter nozzle, when you're trying to print something that's 500, 600 millimeters long, man, it takes forever. Swapping out to a 0.6 or a 0.8 really can take down your print time. And it's not just about layer heights. Sometimes it's all about your shell thickness. So if you have a 0.4 millimeter nozzle and you're doing 3 shells, that's usually 1.2 millimeters. But if you have a 0.6 millimeter nozzle, you can do that same shell thickness in 2 shells instead of 3 shells. And if you're just doing small models all the time, you may never realize a super big difference in print time by saving 1 shell. But as you scale up and start printing bigger and bigger stuff, sometimes saving 1 shell could save hours and hours of print time. So, front roller mounts. In place, they can just be not fully tightened at this point. Let's go ahead and get the front roller on there and get our pulley on there also. This is a 80 tooth GT2 pulley. And we're going to put it on in this direction, and we can get our front roller in place. This is a 12 volt, 30 amp power supply. I guess you can do the math on the wattage if you'd like. So this beam is actually designed to stick out the edge of the roller mount a little bit by design. That way we can attach a little crank to it, which makes moving the conveyor belt under tension much easier. And then I will just tighten up this pulley, and that will keep our rod in place. And then I can lightly tighten the front roller mounts so that everything stays where it's supposed to be for the time being. Later, we will loosen these roller mounts, and then we'll pull them forward to be able to tension the conveyor belt. So the back roller gets pressed up against, or the mounts themselves get pressed up against the back rail. That way, the back roller is totally square with the frame. So then the belt wraps around these rollers. This is square with the frame, and then we pull these mounts forward to create tension on the belt. But like I said, we'll do that later. I didn't go with a slim power supply because I do believe they are more expensive. And again, the whole goal of the project is to be accessible. Definitely worth pricing out as the project goes on, though, because if this was just a little bit slimmer, we could hide it underneath the frame and it'd be a lot cleaner. That'd be nice. So next thing we're going to do is we're going to put our front frame piece on. So let me grab that. This front frame piece is threaded on all of these 4 holes. And then we're going to use some M5x20 screws to put it in place. But before I do that, I'm going to have to loosen some of the back frame pieces. Again, like changing a tire. Things are easier to align when they're not fully tightened. I'm trying to keep what I'm doing in frame, but as the printer gets bigger and bigger, that is going to be a bit of a challenge. Just use this box to prop up the frame a little bit. Make it easier to tighten all these screws. One thing I just realized I forgot to do is I actually have to put a T-slot nut into the bottom rail of this right side frame in between the front roller mount and the front of the frame. And we will attach the LCD screen mount to it later on. Thanks, Danny. I like the frame too. I wanted to keep it minimalistic, and easy to assemble. So there are machined slots in the 2 front frames where the bolt needs to go through and attach to the front frame, and there are also machined holes in the back frame where again the bolts go through those and then thread into these side frame pieces. rotate this around. And retighten these bolts on the back of the frame. I think now is a good time to attach the accessories to this back rail of the printer. So this is going to be our idler pulley mount on this side, our extruder and X-axis motor mount on this side, and our X carriage that is going to roll on the top rail of this rear extrusion. Our idler pulley mount is going to be the easiest, so we'll just do that first. The conveyor belt rollers are small for a few different reasons. The first reason is that by using 8mm rods, it's an off-the-shelf component that I can get from other 3D printer component suppliers. So not having anything custom or not having to interact with more suppliers than necessary makes life much easier. The other reason is the roller diameter affects the steps per millimeter that you need for the motor. There we go. This is a little bit tight, so I'm going to want to loosen these V wheels. So the NEMA 17 motor that drives the conveyor belt through this pulley, so that's a gear up situation, so it'll have more torque. If it had larger rollers, it would, in essence, decrease the resolution that we can get on the conveyor belt axis or the Z axis. By going with smaller rollers, we're able to have that increases the number of steps per millimeter that we need for this axis. And that's important because that allows us to use a standard NEMA 17 motor instead of a geared NEMA 17 motor like the Creality CR30 uses. So that is a pretty substantial cost savings by using a standard NEMA 17 motor instead of a gearbox attached stepper motor. So it's about cost savings. It's also about simplicity because then you have 4 identical motors for XYZ and extruder instead of having one oddball geared motor that you need to drive the conveyor belt. So it's a lot of different factors. Like I said, I'm going to want to loosen up these V wheels. They're just a little too tight for me. I think we're going to stick with 8mm rollers. We might need to move up to 10 or 12 because bending a conveyor belt around a smaller diameter roller is a little bit tricky. It's given us some unexpected challenges with the Formula 32 conveyor belts that we use and that I make. So we're going to see how this progresses. We might need some larger rollers. We might need to make some tweaks to the Formula 32 formula in order to get the best possible outcome. Now we can take our X-axis motor and extruder motor, get that attached. As of 6 minutes ago, we've passed the 2 hour mark. All right. Next, we'll attach our GT2 pull motion belt to this axis right here. For that, we're going to need our bag of motion belts and our bag of zip ties. So in our bag of belts, we have a closed loop belt that's going to be used to drive the conveyor belt axis, and we have 2 open GT2 belts that we use for the X and Y axes. So this belt threads through the extrusion, around the idler pulley and the drive pulley that is attached to the motor. Let's come out the other side here. And then we have cutouts in this sheet metal mount that we will thread the belt through and then zip tie it in place. This is one area for improvement from the betas. I think I'm going to add some more slots in our sheet metal mounts to help with the belt running more straight compared to what it is on this version. It's been a while since I brought it up, so just to revisit again, I think creating the Ender 3 of belt printers can have some massive impact on the 3D printing industry and manufacturing as a whole. I think it being open source is super important, but I also think not just open sourcing it, but making it a product is going to help with adoption tremendously. I think if you go on Thingiverse and you search for open source 3D printer, you will get so many different designs. You'll find belt printers on there. You'll find mods of popular printers on there. You'll find pretty much anything. But how many of those open source 3D printers do people actually build? I think it takes a certain skill level and a certain type of person to want to build a printer totally from source that causes some hurdles with the technology being adopted. I think the White Knight is probably the best example of that. From everything I can tell, it's a good design, but finding a conveyor belt for it super challenging. It costs about $2,000 to build. So if you want to build one, you've got a pretty significant investment. Um, I believe you have to grind down a nozzle, like it's not just an off the shelf part. Um, Whereas the Tinybelt is completely designed around the foundation of inexpensive 3D printers, right? So if you look at the Ender 3, you can clearly see some of the design inspiration around, you know, the V-slot extrusions, the hot end, the excuse me, NEMA 17 motors. It's all standard off the shelf stuff, but designed and configured in a way that it's easy to build, small footprint on your desk, pretty large build volume. I think designing it around standard parts, not expensive parts or custom parts, is really going to help adoption. All right, so our x-axis is belted. Motion's feeling a little bit sticky, but I'm just gonna press forward for now. I'm gonna fully tighten up my GT2 pulley on our x-axis motor. There it is. Losing my hex keys again. Okay, we're looking good. Next thing I think we should do is attach our Y axis, our conveyor belts, or our cantilever axis. So I'm gonna have to grab that extrusion. And I might have to stand up for the rest of this build. We can loosen up these T-slot nuts, and I should really clean up this table a little bit. And my microphone just came out of the mic stand. This will actually be a good opportunity. I forgot to add these washers to the uh, x-axis carriage. Without those washers, the 10 millimeter bolts on here will be too long. That's not good. There we go. Let's try to get as much of the printer in frame as we can. I might have to raise up the camera a little bit to get more of it in frame. So we're going to take this washer. Going to take the washer, put it on the M5 bolt, and then put the T slot nut on there. Maybe next time I do one of these builds, I'll have to get a lav mic instead of the static mic, because as this thing gets bigger, I'm going to have to move around. Now we can slide our y-axis on. When I'm attaching this arm, I like to, uh, again, tighten these bolts, but also keep them loose, and rotate, alternate back and forth between the two of them. And I do this so that it can self-locate in the V-slot channel. So the T-slot nuts, um, the inside of them should perfectly match the inside profile, within uh, plus or minus a tenth of a millimeter, something like that. So by tightening slowly and alternating between them, you can help them self-locate in that channel, and that way we won't accidentally get the channel at an odd angle apart from the intended angle. So our intended print angle is 35 degrees. I chose that angle instead of 45 degrees, like a lot of people think it is, because the filament flow path is more perpendicular to the conveyor belt, so that helps with the plastic actually sticking to the conveyor belt. And it also helps with overhangs on the leading face of parts. Overhang angles work differently on angled axis conveyor belt printers. I have a couple articles on our website on how part orientation and overhangs work if you're interested in diving in more. Next, I think our goal should be to attach our hot end carriage, also our y-axis carriage. But before we do that, I think I want to spiral wrap and add a PTFE tube to this, for strain relief. So let's do that, and I'm just gonna take the printer off the table for a second. We'll focus on this. The printer will print as fast as you tell it to go. That's not exactly true. Um, in my print profiles, I will usually print between 15 and 45 millimeters per second. So that varies between the shells and infill. Um, in the infill, I might crank it up to 40 millimeters a second, or 45. But on the shells, usually I go slower. Um, and this is one thing that I don't hear a lot of people talk about in regards to conveyor belt printers. Um, if you're familiar with 3D printing, you know how important it is to have a very good first layer. And usually, that first layer is going to go slower than the rest of the print to help make sure that the plastic sticks where you want it to stick. So here's where belt printers differ. The outer shell of the model is always intended to touch the conveyor belt, meaning your outer shell, at least part of it, is always a first layer. And therefore, you have to, for best results, in my experience, of course, um, have a consistently slow outer shell. So typically, in my current print profiles, The outer shell is going to be something like 15 millimeters a second, which is pretty slow. Inner shells, you generally want to have it close to the outer shell speed so that there isn't like a stark difference of it going 15 millimeters a second and then 60 uh, on an extrusion that is so close to the outer shell. So 15 millimeter per second outer shell, 25 millimeter per second uh, inner shell, and then crank it up to 40 or 50 uh, around there, depending on the filament for your infill. It's an interesting topic, kind of a nuance of belt printing. I have these little notches to guide the wire for the part cooling fan, and then I'm going to want to zip tie for wire strain relief to the top here. Let me find those zip ties. And feed this through designated holes here. So I clipped the zip tie together. That means I'm going to have to feed all these wires and the spiral wrap through that loop also. Could have thought ahead a little bit more than that. If you guys have any more questions about the Tinybelt, about belt printing in general, feel free to fire them off in the chat. I'm happy to answer them as we're building here. So let's feed these wires through. I've gotten the ribbon cable comments a few times before, probably inspired by this mess of wires that I'm fumbling with. Um, Man, ribbon cables seem nice, but that increases the complexity of a printer, and it makes it so that you need more custom parts. Um, Again, just trying to work within the scope of off-the-shelf open source designs that kind of takes ribbon cables off the table. It increases costs, all of which is kind of outside the inspiration for the project of becoming the Ender 3 of belt printers. I'm going to tighten up this zip tie. We've got our wire strain relief in there. So then we're going to bundle all of these wires in the spiral wrap, spiral wrap, um, with our wire strain relief tube. Wiring is absolutely my least favorite part of any 3D printer build. Um, if anyone out there watches the Spacers guy, I'm forgetting his name off the top of my head. You know, he builds giant 3D printers and CNCs and all sorts of cool stuff on YouTube. If I could remember his name off the top of my head, I would for sure mispronounce it and embarrass him anyway. Not embarrass him, embarrass myself and my poor ability to pronounce things. Um, I think he also hates wiring. Just feels so tedious, you know? But you just gotta do it once, and then it's done. If you tighten the V wheels enough on the rear V-slot rail, you should have no troubles with movement, changing the print angle when you're printing. Obviously, design's still being tested, trying to figure out appropriate V-wheel tightnesses. Screws can loosen over time with vibration. So there's variables there. But from everything I've seen so far, the cantilever design is working very well without any wobble or movement. Some of the beta testers who have built their machines so far have been like, well, if you push on it, it moves. And I'm like, of course it does. It's not going to be like it is. It is still a cantilever. I think if you try to push on the arm of a Prusa Mini, for example, it's going to move too. Or an Ender 2, I think, is another cantilever printer out there. If you push on it, it's going to deflect a little bit. If you push on the side mirror of a car, it's going to move a little bit. Like, you won't want to stand on it, but that's absolutely not like the usage intent of the designer of the printer. If you've been hanging out on the stream, um, I'd like to invite you to subscribe to the YouTube channel. So a lot of people don't know that YouTube runs ads nowadays on every single video, even if the creator doesn't have um, the right statistics to qualify to earn money from Google AdSense. So YouTube runs ads on videos that I create, and they take all the money earned from those ads without paying anything. And that's just kind of the tough part of being a small creator. So if you are familiar with me from Twitter or Instagram or any of those other places, if you feel like donating a subscribe on the YouTube end of things, it would be much appreciated if you haven't already. It looks like I cut the spiral wrap a little short, so I'm going to grab a little bit more. Um, Notice that right now I am separating the wires themselves from the uh, wire strain relief tube. So these wires will run to the control board, and this area will be connected to the wire constrain mount on the printer. Let's throw some more spiral wrap on here, and then we can get this subassembly all hooked up to the printer. That's right, Nate. The strain relief tube is just a cheap Bowden tube being used for a different purpose. Um, it was easy to get from the same places that I source other 3D printers component. I'm not sure if it'll be a permanent design decision, but for right now, for the betas, that's where we're at. I could probably use any cheap semi-rigid plastic tube to serve this purpose. Now we can welcome the printer frame back to the kitchen table. Slide on our hot end roller, and I'm going to want to constrain uh, our wire stack over on this side of the printer. And I messed up and forgot to slide a T-slot nut into the frame, so I'll have to loosen a couple things and get that done now. You know, some amazing things in business and technology have been achieved from a garage or a spare bedroom or a kitchen table. So that's where we're at for today. So all I'm doing is I'm loosening, taking off our front roller mount so that I can put a T-slot nut over here for our wire strain relief part, which is this right here. See, even though I designed this thing and have built a handful of them, I can still forget some steps. And because I don't have a dual monitor setup at my kitchen table, I wanted to keep the YouTube stream and the chat open so that I can respond to things. So I don't have the assembly guide open. I can reattach the T-slot nuts to the front roller. And I'm struggling with this a little bit, so I'm just going to make my life easier and attach the T-slot nuts to the M5x10 bolts outside of the frame and sliding it back in. Spare bedroom looks like a droid factory blew up. I love it. I have a home office, and then I recently started renting a real, very small, but still an actual office space for Powerbelt. And I'm going to focus on getting this roller mount on there, and then I'll keep continuing with my sentence. Anyway, so I have a home office that is definitely a mess, because things actually get done there. And I also had for a while printers in our spare bedroom, which my wife usually has to go into her office to work. But on the rare occasion that she works from home, she really had no place to work other than the kitchen table, because I was occupying both spare bedrooms as an office and as a 3D printer holding area. And that is not something that she wanted to be a thing for all time. So had to clean that up, put more printers in my office, and not in the spare bedroom. And now she has a spare office and a guest room instead of me just having two offices. Totally reasonable request from my awesome, very supportive wife. So now I'm replacing the M5x20 bolts in the front of the frame, and we are quickly getting back on track. Next step is to attach our wire strain relief mount to this side of the printer using the T-slot nut that we just put there. And I'm going to grab an M5x10 bolt. And the exact placement of this mount doesn't really matter. It just needs to be on this side somewhere. And next, we'll zip tie this in place. And then we get to actually start connecting some of these wires to the board. for everyone watching, I'm curious how many 3D printers you have at home. Feel free to chime in the chat. How many 3D printers do you have? And if you have some FDM and some resin, let me know that too. Two printers. So I started with two printers. And then I bought a resin printer. And then I've recycled components from so many printers. 8. Oh, Gerardo's here. Thanks for joining. I'm stripping off a little more of the insulation off of these hot end wires. 8 printers is impressive. 11 working. I have a feeling some of those printers are not up and working at this point. I have to do some repairs. Anyway, I had 2 FDM printers, and then I got an Anycubic Photon that was on sale. That's been fun to mess with for some high detail stuff and some watertight, airtight stuff. We got 6. We got 5. I think Mad Monkey is in the lead. If anyone can beat 11 functional printers, feel free to chime in. All right, we've got our wires trimmed. Let's get stuff connected to the main board. Three Delta, 3 Cartesian. I have never owned a Delta printer. Yeah, I'm not totally sure how this is gonna look on camera. But I'm just gonna try my best. Delta printers do look super cool in motion. Since you're in Michigan, those are CME CNC 3D printers, aren't they? I think they were one of the first um, consumer level 3D printer companies in the U.S. back in that MakerBot era. One of the things I'm not crazy about with these SKR mini boards is um, in the V2 version that we're using, they rotated the power screw terminal so that it doesn't face the same direction as all the other screw terminals. So it just makes for a really strange hookup here. So what I do is I grab the cable with pliers, and I put it where it needs to go, and then tighten it down because it's a tight fit. So I've heard great things about Delta printers, and I've also heard some horror stories about Deltas, like an FL Sun Delta. I think that for a while was the most affordable 3D printer you could get off of AliExpress. I think they're just tough to calibrate for some people. Mad Monkey, do you have a Scara printer? That came up earlier in the stream. There's also polar kinematic printers, which have never really caught on. Super interesting though. All right. So that's our 12-volt power. That's all connected. So we have two fan connections. I always forget what these white connectors are called. So these connectors are identical, which makes it a little tough to figure out which is the heatsink fan and which is the part cooling fan. But as soon as we boot up the printer, it should be very easy to figure out which is which, and then we can swap them if we have to. This is the thermistor connector. And then we can connect the hot end heater cables to the correct terminal. All right, so that's everything from our hot end mount. So the other things that are left are the LCD screen, the Z motor. We got to add the belt to the Y axis. So we're making progress. Um, let's start with the belt for the Y axis. So this belt is going to feed through the aluminum extrusion. Let's start with the top. I have been calling the mostly built printers 90% assembled. So essentially, everything would be assembled except we would take this arm off for shipping purposes. Probably put it over here in the box. So you would need to take everything out of the box, attach the arm, and attach the LCD screen, and then you'd be good to go. If I could ship it fully assembled and not spike up the shipping cost, I would. But shipping it with the arm attached would spike up the shipping cost. So I'm going to make a loop on this GT2 belt. This is small, so it's going to be hard to see. And I'm going to zip tie that in place. Then I'll put that around one of the bolts. So this will be one side. Connected, and then we can put our idler bearing holder mount up top. Wrap the belt around our other M5 screw and we'll zip tie that in place. Trim some of this excess zip tie and some of the belt off. Danny, I'm not totally sure what the amperage or the weight on the stepper motors are, but they're 35 millimeters in length. They're 1.8 degrees, 12 volts. Exactly the same sort of thing that you're going to find on an Ender 3 or any other printer in that. Next, we pull up on this idler pulley mount. That'll tension our motion belts, and then we can use these M5 bolts to tighten it in place. So now this moves and is all connected to our NEMA 17 motor. I'm going to adjust the spacing of the pulley on our y-axis motor. We're in line with the groove of the V-slot extrusion. And I will probably have to retighten. That's looking okay. That's feeling okay. All right. Y-axis is done. Wiring is done. I goofed up and ran the wires under the frame when they should go over the frame so that the frame isn't sitting on them. So let's redo that. I really hope this printer is a game changer. I've been working on making belt printers more accessible since my first prototype in 2018. Um, it's been a long few years of learning and improving and learning what people want to see from a printer versus what's uh, price friendly. Um, so I'm learning and improving, as much as I can. Uh, so, all right, we have to add the Z conveyor belt motor next, and we have to add the LCD screen, and that is all the components. Then we can start wiring up the steppers for motion, making making good progress. I'm gonna take a quick break and refill water. So stay tuned, and we'll keep trucking. Okay, we are back. Let's keep moving. Z motor next. One thing I forgot to do was attach our closed loop pulley to our front rail. So we'll loosen this up and put that on. Something I don't think I mentioned is that I tried to use as many 3D printed parts as possible when designing this printer. And that is a choice that's much different from what I did for the Zero. So on the Zero, my thought was if I don't have to do it in house, that's going to be a huge advantage, right? Because, printed parts take a long time to make. Um, you run the risk of, not being able to ship printers if you are waiting on your printers to make parts. I think you can look at Prusa, and they regularly have a multi-month lead time for their printers. And I imagine that in some ways that could hurt their sales for people that don't want to wait. So my thought was minimal 3D printed parts, right? As few as possible. Um, use things like sheet metal parts everywhere that I can because they're reasonably priced. And also, you can get them pretty quickly, right? If they're simple shapes. Um, but what I didn't realize about sheet metal parts was that they are heavy. So even if the parts are pretty inexpensive, shipping parts to me can be very expensive. Um, and on the back end of that, shipping printers to customers is expensive. Um, just because steel heavier than plastic for a part that performs the same function. It also makes it much more difficult to change the design at any point. So, for example, these heat bed mounts, if these were made out of sheet metal and the heat beds had come in, and like I mentioned earlier in the stream, they were bigger than I expected, I would have had to throw away all of these heat bed mounts, um, throw them away, order new ones, um, and that would all cost a ton of money. I'm just trying to get this front roller back into position. We've passed the 3 hour mark as of 3 minutes ago. Here's our Z motor mount. I'm going to attach our Z motor to that. All right, now let's grab some M5 bolts and T-slot nuts, and that'll allow us to put it on the frame. We won't need it to be super tight or anything because this won't be its final position. I'm gonna put a GT2 pulley. Whew, sorry if that was loud, you guys. Put a GT2 motion pulley on here. Again, this probably isn't its final location on the shaft, so no need to tighten it fully all the way or anything. Okay, Z motor is on. Next, the LCD screen, heat bed. This is our LCD mount that goes over here. Here's our LCD screen. I went with a touch screen, and also here's our duck. I went with a touch screen that also has a click wheel. I'm still kind of learning exactly how both modes can be enabled. I think the cables that they sent with this one don't actually allow you to switch from a click wheel menu mode over to a touchscreen mode back and forth. Touchscreen only. Hopefully, I will get those cable challenges sorted out for the launch so that you can choose whether you want to use the click wheel to control your printer or the touchscreen. But the touchscreen interface has been okay for me so far. So no challenges there. We're gonna need some M3x5 screws to attach the LCD screen to the mount itself. There's 3, just need one more. There we go. I have to take off the click wheel to fit it into the mount, and then we can replace it. I did a Q&A practice live stream yesterday just to make sure video, audio, all that was working out. So if you weren't a part of that stream, you can go back and watch it. It's still public on my YouTube channel. But one of the questions that people have asked um, pretty commonly is when does the campaign launch? And at this point, I'm looking at January for a launch because people just get so busy during the holidays. And another question I answered was how long after the end of Kickstarter um, would you be able to ship printers? Um, and while I would love to start shipping like the day after the campaign ends, it's just not practical. So based on all my experience getting parts um, into the U.S. from China, um, it's really difficult, if not impossible, to ship in less than 90 days. It just takes time for things to be packed on their end, packaged up, shipped over, cleared through customs, all that sort of thing, especially because we have two sheet metal parts and custom aluminum profiles that need to be machined. Um, it becomes super difficult to ship any product of this level of complexity in less than 90 days. Um, so that's kind of my goal at this point is to have the Kickstarter end. Usually it takes 10, 15 days after the campaign ends for Kickstarter to actually deliver the funds to the person who's running the project. Um, 15 days after that, um, during that 15 days, I can get quotes from suppliers, um, place orders as soon as possible once funds get in, um, and then get started printing parts. That way, when the electronics and everything else shows up, I've got a whole bunch of printed parts ready to go. And we can start shipping, as fast as possible. Here's our cable for our touch screen. We're going to have one end attached to the LCD and the other attaches to the control board. So that's the LCD side. And the LCD attaches to these 5 pins. And at this point in the process, I think we're ready to try booting up the printer, verifying that our fans are connected in the correct places, and also um, after confirm that, we can start wiring up our motors, attach our conveyor belt, and heat bed. So moving right along here. Gonna have to grab the power cable and get this plugged in. In answer to your question, yes, the firmware will be open. I want people to be able to hack, modify, make changes to this machine, kind of as they get used to it. So definitely open source firmware. I think again, part of the appeal of the Ender 3 and similar machines is that it is open source, so people can make it their own. Yeah, that little control board box is super helpful. Sometimes I have the I have a roll of blue tape that I use to prop up this frame in different positions while I'm building. Um, but my blue tape is somewhere else, so using the control board box, and otherwise it just gets thrown away. So why not? The heat bed dimensions are 325 by 325 millimeters approximately. In working with my suppliers, um, they have said that that is the standard size for a 300 millimeter build volume printer. So it would be a 300 millimeters in the X, 200 millimeters in the vertical dimension, and then infinity millimeters on the conveyor belt slash Z axis. I realize a lot of what I'm doing off camera is hard to see. I'm trying to work with a short power cable and still get it to connect to my closest wall outlet, which is proving to be a little bit of a challenge. Maybe I can sell that box, but I've never really wanted to be famous. It seems like a lot of hassle. Really, I want to have a positive impact on the world, and maybe that involves being famous, but hopefully not. Hopefully, I can just be myself. Um, Power cable. I have another power outlet on the other side of this table that I'm gonna try to use. So one moment. Okay, so we are plugged in to the outlet, but I'm really gonna have to get an extension cord of some kind to be able to work with this. But let's see if we can power her on. Okay, power is on. However, I'm not getting any lights on the LCD screen, which means I believe the wire connector is backwards. So let me flip that and we can try powering on again. And I'm gonna grab an extension cord. Okay, extension cord acquired. That's gonna let us stay in frame without having to redo a bunch of stuff. And let's flip this connector around. Okay, let's power on again. Still not getting anything from the LCD, so that's just... I'm getting LED lights underneath the control board. So looks like the control board's getting powered, but I'm not to the LCD screen. Definitely looks like it's connected in all the right locations, so I'm genuinely confused at this point. Still no lights on the LCD, so I'm gonna see if we can connect uh, over USB to the printer. Um, Figure some things out that way. The included cables with these boards are pretty short, so I'm gonna have to grab a USB extender. Uh, Hurdles like this were bound to come up as much as I tried to be prepared. So I will be right back. Feel free to treat yourself to a break. USB extender acquired. Plug it in over there. And I'm firing up Repetier host just to see if we can connect in any way to the printer. Connection successful. I'm going to turn on the part cooling fan and we can figure out which one of these fans turns on. It's the heatsink fan, so that's not good. We're going to want to switch those connectors. So power down, disconnect from the printer. Swap these connectors. And I'm pretty bummed that this LCD doesn't seem to be working. Maybe I'll troubleshoot it at another time. Um, as of right now, let's put firmware beyond the stock firmware onto this control board. So how this is done is you're going to need a micro SD card. I'm plugging it into a USB adapter to connect to my computer. And from there, you need to put a firmware.bin file onto the root directory of the SD card, and then you need to power on the board. That's it. So this SD card has a whole bunch of stuff on it that I'm just going to get rid of. And then I can grab my firmware file, put it on, and flash the firmware that way. One second while I locate the firmware file. Yeah, Eric, because we do have an infinite Z capability, you could totally print plastic versions of the extruded aluminum. Um, it could be fun. I did an I-beam last night, but I'm not sure it makes financial sense, which kind of makes me sad, but it is what it is. Um, and I am really struggling to find this firmware file. Um, so anyway, um, the aluminum extrusions, even custom machined, are pretty affordable. And I'm not sure you would get uh, enough cost savings versus quality to um, really make sense. I think the decrease in quality you would get from having a plastic frame wouldn't offset the cost savings you would get from making an aluminum version. So I found my file, putting it on the root directory of the SD card, micro SD card. Apologies. Now I will eject this drive. And we can take our micro SD card, put it into our printer, and let's boot it up. Okay, let's connect over USB again, just to make sure nothing broke on us. All right. Still connected successfully. Turn on the part cooling fan, and the part cooling fan is working as intended. All right, let's shut this off, and then let's do our motor wiring. So we are going to have to wire the XYZ and extruder motors. Here are all of our cables, and we'll have to wire wrap these. This is also a good time to install our end stops, so I might as well do that. All right, got our end stops. So one end stop mount gets mounted on the aluminum extrusion of the y-axis, and our X end stop gets connected directly to our uh, X and extruder motor mount. Let me get this. Let's start with the end stop. For anyone wondering, the motor drivers are TMC 2209s, so they do support sensorless homing. But one thing I learned through our beta testing process is that sensorless homing can be very finicky. Something I didn't quite anticipate. And so we're using end stops now. God, it was just so much easier. Little things like the tightness of the V wheels on the extrusion can affect the sensitivity that you need to set um, in the firmware. So it quickly became apparent that if I was going to make these 3D printers and sell them uh, in larger volumes than like one or two, um, tuning that motor driver sensitivity for every single printer just was not going to work at all. So decided that adding some end stops would be just an easier option for everybody. Some of the testers did successfully tune their sensorless homing settings. I fought with one machine for about a week, trying different values. I never managed to get super consistent results. So I ordered some end stops and have had much better luck doing that. Um, Using end stops, much easier. I even heard from some of the beta testers that they have machines with physical end stops and that do sensorless homing. Um, but if they're ever building a machine from scratch, they choose physical end stops just because the tuning process can be challenging. Here's our end stop for the y-axis on its printed mount. We'll just adjust this at an arbitrary spot. Yeah, Eric, for the purpose of prototyping, totally works to 3D print um, a V slot extrusion um, just for form fit purposes. Totally makes sense. Um, but yeah, aluminum is it's cheap, it's lightweight, it's relatively easy to machine, which has got to be why it's so popular for so many applications. Comes in different grades, goes through an extrusion die easily. Dropped our other end stop, but I found it. All right, looks like we are down to 6 concurrent viewers. So for everyone who has stuck with me as the build uh, probably gets less interesting as we get down to some of these smaller assemblies and specifics. Thank you for sticking around. Um, let's get this end stop in place. I swear there was a hole that this part that this screw needs to thread into. But man, I'm having a hard time finding it. I'll try the other mounting hole and see if that's any easier. I think part of my challenge here is that all the printed parts are black. And even though the camera lighting looks okay to me, um, my actual build lighting could be could be improved. All right, now I think we're really getting somewhere. Yep, now let's grab our other mounting screw, put that in place. Okay. Both end stops are attached, and I wanted to get those attached before I did any wire wrapping because I want to wrap them into the same uh, bundle, I guess, as the motor wires. I like to start the X and extruder motors together. So let's find those wires and let's just get this end stop cable out of the way. Yeah, I suppose plastic is cheaper than aluminum, uh, but not nearly as rigid. There are some high performance plastics like carbon fiber or Ultem um, that can have comparable stiffness to aluminum, but then they're way more expensive than something like PLA. So pretty quickly, aluminum starts to make sense if you want something that is very rigid that makes for a nice sturdy frame for a printer. And I think that's why V slot extrusions are so popular. I think if something better, easier, cheaper um, existed in today's world, uh, you know, Chinese manufacturers are so good at uh, cutting down the price of things. I think someone would have figured it out, and I think some people, God, I forget the name of the some of the small printers that have um, injection molded plastic frames. Hey, Auto Drop 3D is here. Thanks for stopping by. Um, as I was saying, cheaper printers that have injection molded plastic framing components. Um, I think they're fine, and they're probably cheap on a per unit basis. But if you are a single person or a startup, an injection mold by itself can be, $10,000, $20,000 depending on the complexity. And then if you need that for multiple frame components, it's a really big upfront cost um, to be able to bring a printer to market versus the V slot extrusions are mostly an off the shelf component um, that we need to do some small customizations to for machining. Um, which every supplier that I have worked with, and I've rotated through a few different aluminum extrusion suppliers, they're happy to do the machining for you. It adds some cost, but they're happy to do it. So send them uh, send them some technical drawings where you need your holes, where you need your threads. They're more than happy to do it. As an alternative, if you want to avoid the injection mold and just print all your parts, um, again, you start to run into cost because um, printer filament is much more expensive than plastic pellets, which you would use for an injection mold. Sorry, I didn't really finish my thought there. Plastic pellets in bulk are used for injection molded parts. Um, weeds of, oh, well, you need a pellet extruder, you need an automated printer, all this sort of thing. I am printing at 35 degrees, not 45. In my experience, 45 works nicer based on the path that the melted filament has to flow. It helps with belt adhesion. It also helps with nozzle shape. It also helps with overhangs on the leading faces of prints. So 35 degrees I find more functional than 45. Um, Not that 45 can't work nicely, but it's just my preference. Um, these wires are nice and organized. Next, let's do our Y-axis motor and end stop. So far, I'm feeling pretty good about my time estimates. I was on a video call with someone the other day, and they're like, "How long does it take you to build one of these things?" It's like 4 or 5 hours, um, and we are under the 4 hour mark. Um, but so far, all we really need is attach the heat bed, attach the conveyor belt, um, and we should be up and running. So feeling pretty good about that. It's always easier once you have all of your parts in front of you, all of your tools in front of you, compared to I know I've had to take a few breaks and grab something that I forgot. USB extender. I suppose it also helps that some of the sub-assemblies, um, I had batched small parts of it. So at my office, I've got, full assemblies of this extruder and X-axis mount already together. So when it comes time to build some of the 90% assembled beta printers, um, it'll be really easy just to slide the frame. Spiral wrapping must be one of the most fun things in a live stream, I'm sure. But it's a part of building the printer, so this is what you're here for. And like I said, we're getting to the the finish line. In my brain, I was gonna say we're getting to the end stop, um, which is hilarious because it's 3D printer related instead of race related. All right, wire wrap. Thought I had another small section somewhere. I guess not. We'll trim off part of this one. Auto drop. Some people were asking earlier what I thought of the iFactory conveyor belt, and having never used one, I didn't have much insight to share, but if you had an opinion of it and wanted to share it, I'm sure other people in the chat would appreciate it because I believe you've tested one or have one, something like that. Okay, I think that's enough spiral wrap for this segment, and then we can attach. I don't want to attach things to the board yet because we've got one more uh, motor cable for the conveyor belt slash Z axis. Let's get some of these screwdrivers out of here. An iFactory, a CR30, and a mini belt printer. Of those, which one is your go-to? Okay, that's what I was doing. Wire wrapping one more motor cable. It's always easier to wrap a single cable compared to a little bundle of cables. So this should go real quickly. Interesting. Yeah, I think pre-release is super interesting when it comes to crowdfunding campaigns because from what I've seen online, um, the the CR30 was, and I could be getting this wrong, was marketed as this is done. Like we're we're shipping out tons of these. Um, we we're not going to make any changes to what people get from Kickstarter, but lo and behold, there were changes, especially to the conveyor belt, and then people had adhesion issues, which isn't good. See, the belt was different, and it's been an ongoing conversation in our beta testing Discord of people have been saying things like it needs to be as complete and final as possible before even launching the Kickstarter. And while I agree that it does need to be as done and complete as possible, I think the as possible phrase is really the key there because I think that the CR30, the iFactory, like no matter how final they thought things were before and during the Kickstarter campaign, like changes were still made. Um, I think it's unrealistic to say that there will be no changes whatsoever because if you find a better way to do something or a cheaper way to do something um, during in the middle of a campaign, don't Seems silly to just ignore that for the sake of saying that you didn't change anything. Cloth belt that has been doped. Not totally sure what that means. I'm glad it's working well, though. I think I'm really happy with our Formula 32 conveyor belts. They've been working well for me. Um, I've made them in a whole bunch of different sizes. All right. Cable is wrapped. Now we can plug cables in to where they belong. This is our Z. The Formula 32 conveyor belts have a smooth PET film top layer. I recommend glue stick if people have adhesion issues, which is pretty standard, I believe. I do have a number of things that are half-baked to improve upon the Formula 32 belts even more. But considering they're half-baked, they're not ready yet. All right, just trying to figure out how I want to position this printer to plug everything in. I did not mark which of these cables were X and which is the extruder, so we wait in and then run some test commands to determine for certain which is which. So we'll just plug these in for now. And our X end stop also. And plug in the Y end stop, the Y motor, finally the Z motor. So the only thing that isn't plugged in yet is the heat bed, but I think I want to run some test commands and make sure everything else is working first before I put the heat bed on. And we're going to try plugging in the LCD again to see if we can get some lights up there. I'm seeing that I accidentally put the Z cable underneath the printer. That's not going to do. So I'll instead route it back behind the power supply and under the printer that way. Cable management has never been my strongest talent. I try to focus on just whatever functions, but it has improved over the first couple times I put one of these together in the full beta context. I'm gonna pop out the micro SD card, put it back into my computer to confirm that the firmware actually flashed. I think that might affect the um, effectiveness of our LCD screen. So when the firmware flashes, it consumes the firmware.bin file put on there, and it replaces it with a firmware.cur file. So I confirmed that there is no longer a firmware.bin file on the micro SD card, and instead there is only a .cur file. So firmware should be loaded safely on the board, good to go. My power cable got disconnected from the wall, so let's grab that and boot it up again. I'm now seeing an LED indicator on the back of the LCD screen. So now I'm even more confused why it doesn't seem to be working. I'm pretty surprised because overall, the LCD screens that I've opened up have all been functional. Like I haven't found any yet that are dead on arrival. So it's strange. But let's see if we can get this thing moving. Just with connected to my computer. For the Kickstarter, I will only be one bed size. That bed size is 325 by 325 millimeters to create a build volume of 300 on the X, 200 in the vertical direction, and then in the conveyor belt axis. Down the line, I've intentionally made this frame very scalable, so I could totally offer bigger or smaller versions in the future. But for the Kickstarter, since I'm just getting going, I think it's to keep things simple, um, and yeah, keep things simple. So one bed size. I still think it's going to be the right balance of affordability and capability for what most people will like. All right, we're moving our y-axis. Um, I can feel that the extruder motor is moving when I'm trying to jog the uh, x-axis. So I did get those cables swapped. I'll have to swap those. The other thing I want to do is enter an M119 command. This will check our end stops, which is important if we're going to try to home this thing. All right, so now you guys can't see this, but in Repetier Host, it's now saying that the Y min stop is triggered when I press it, so that's great. X min end stop is triggered, also good. So let's swap, let's disconnect everything, and then swap the uh, X and extruder motors. All right, we are powered on. We are connected over USB. That is our first move on the X-axis. We've got a Y-axis. Let's try to home X. Success. I'm going to move the Y up a little bit because I don't want. Yeah, let's just move this up. What you see I just did there was I slid the Y end stop up this extrusion. That's essentially how you're going to set your nozzle height off of the bed later on. You'll see. Let's try homing Y. Perfect. Let's power off those motors again. Let's see if we can jog Z. That's this motor here. It appears it's going in the wrong direction, but sometimes that has to do with the Z end stop, which it kept saying it was open from the M119 command that I sent. So what we need to do is we need to put a jumper on one of the terminals of the control board so that it thinks. I think that's what we need to do. So every control board comes with some of these little jumpers if you want to enable sensorless homing. Already talked about sensorless homing. I tried it. Wasn't super happy with how everything was working out. It ended up being really finicky. So went with physical end stop sensors. From where we're at now, I'm comfortable attaching the heat bed and closing up the control board. So I'm going to go ahead and board off, disconnected. This is our heat bed. I'm going to rotate this printer. Get the jumper in place. Maybe that will help with our conveyor belt axis moving in the right direction. Maybe not. I might have to adjust a couple things. Got some questions coming in. Consider homing the arm to the tip rather than the bottom. I hadn't thought of that. That would be interesting. And then you could just set the offset. Yeah, that's an interesting suggestion for sure. Um, we would need to run the wire in a really strange way to work off of the tip of the arm. So I'm not totally convinced that's our best option. Versus just being at the bottom here, we can just bundle it with the motor cable. Um, but definitely an interesting idea. Since everything will be open source, there's no reason why you couldn't if you wanted to configure yours that way. So our next goal here is the heat bed. So I said it before, but this is our 325 by 325 millimeter heat bed. It comes with a thermistor, all integrated. I'm going to use this last little bit of spiral wrap to tidy up the wires. Where to place the cables on this heat bed has been a fair topic of conversation amongst our beta testers Discord. Um, I like putting them over on this side and then routing the cables under the uh, between the bed and the frame, just like all these other cables that I've been routing. Some people want it to be as close to the control board as possible. Really depends. Yeah, I've tried a bunch of different things with the heat bed and having separate heating zones and cooling zones. Um, Really, the big motivation here is again just to design around standard available parts. Like this is a standard off the shelf rep wrap open source uh, heat bed. So it just makes life easier for sourcing. You don't have to do anything custom, which just skyrockets the cost so quickly. I am going to have to strip these wire cables. For whatever reason, the thermistor cable is way longer than the heat bed cable. I'll probably use a twist tie just to bundle this up a little easier. This is all going to be hidden underneath. I'm happy with this amount of spiral wrap to make sure the appearance works. If you have been tuned into the stream this entire time, um, I would invite you to say hello again, um, because we are at 4 hours and 14 minutes. So uh, say hi in the chat so that I can appreciate your dedication. Danny, I think I know you're one of them. I just gotta say again, I'm really bummed that the LCD doesn't seem to be working. All right, JDC AMC. Hello again. Thanks for sticking with me. I'm gonna get this heat bed out of the way just so we can get it wired where it needs to go. So here's where the heat bed thermistor needs to be connected, and then the heat bed connects to a screw terminal, which you can't see, but there's a screw terminal right next to the hot end heater. I think I need a webcam connected to a set of glasses so that you can see exactly what I'm seeing. I'm not sure they make those. That's right, True Tech. You've been with us this whole time. Gene, thanks for tuning in. Gene is one of our beta testers. He got his box of parts edition, very similar to this one that I'm building. I got your order for another uh, conveyor belt. However, right now I am out of PET film. I ordered more. I don't know if you saw it in the Discord, but it might take up to 10 days to get here. So I I hope that's okay, and I appreciate your patience. Um, you may have seen this. You may not have. My thermistor came loose. It is taped in place with what I believe is thermal paste. I'm gonna grab some green tape and just secure it again. This is the green PET tape that I use to attach conveyor belts. Um, it's got some similar thermal properties to like Kapton, if you're familiar with that. I think it has a slightly lower melting point, but it's more affordable. Um, and I like it as a print surface much better than Kapton tape. I used Kapton tape for ABS on a MakerBot replicator at one point, um, but I think it's really only good for ABS. I'm gonna grab our heat bed springs now. Here we go. I'm also going to need our control board case lid that I stashed away. We're gonna need some screws to attach that. All right, we've got our screws. Let's get our control board case buttoned up. I think it's worth saying, since you guys have been staring at an awkwardly positioned printer for a little bit while I work on this control board um, upside down. Um, Originally, I didn't want to put the control board underneath. It was supposed to be on the side of the printer to make all this wiring and firmware flashing and everything much simpler, easier to access. But because the heat beds that came in were larger than I expected, um, I had to move it. So now it's under the printer. I don't think it's ideal. I think for the launch, I'd still like to move it out and to the side up on this top rail from your vantage point. But for now, we got to work with what we have. And now I'm realizing that it might be hard to get the heat bed out from where it is based on the wiring situation. Let's see here, because the heat bed's over here, but it needs to be over here. All right. Well, that's going to make life much easier. Won't have to remove the control board case. Yeah, sorry for the squeaking sound. Not the most pleasant. That is the screw threading directly into the printed part. That's how you know it's nice and snug. All right, control board case is closed up. I am going to use this twist tie to tidy up this thermistor cable. That's just unruly. Okay. Got our heat bed. We can attach with the heat bed mount screws that I got right here. This is really coming together. I'm gonna have to adjust where the heat bed printed mounts are. I'm gonna have to adjust these front roller mounts, their position. All right, so we've got each of these bed spring kits comes with a bolt, a thumb screw, and a spring. I like to start in this back corner. We can slide this arm out of the way. The order that you do these in doesn't really matter, in my opinion. But I have found that this one is kind of the hardest to get to because of the power supply and all that where it's located. So that's why I like to do it first. And we can tighten this up. So at this point, I can feel that the screw has gone all the way through the thumb nut on the on the bottom, and then I can just use a hex key to tighten it up. Right now, it just has to be a loose fit. Just to get the heat bed in place. Then we can move to another corner. So these thumb screws are a little difficult to get to. Typically, what I do is I adjust the bed height using a hex key, like you can see me doing now, and then I will just hold the. Uh, it's not a wing nut. I really don't know what to call this. It's a little knob. I'll hold the knob on the bottom to be able to tighten it. But I'll actually do the adjustment using the screw head. Now we'll move to the next corner. I'm going to take off this power cord. It's interfering with my ability to move this printer around. We're going to have to move the heat bed mounts forward so that they actually match up with the holes. It's no big deal. I just kind of had them in an arbitrary position when we first slid them onto the frame. There we go. That way the hole in the heat bed aligns with the mount, the printed mount that attaches to the frame. I'll do the same to the side closest to the LCD screen. Let's do the power supply. Again, not that it matters. All right, last corner. Okay, all of our heat bed springs are on. Next, we want to prepare this to attach the conveyor belt. So, if you go to the YouTube channel, we have, well, actually, I made a guide a while back on how to replace the conveyor belt on the Zero, and really we're just going to be doing the same process here. So the first thing I want to do is I want to tighten all of these bed springs down to the point where the heat bed is below the very top of the rollers. So again, I can just hold the thumb wheel on the bottom and use a hex key to tighten this up. And it's looking like my heat bed mount is a little too close to this back roller. This can be loosen the M5 screws that attach the roll the frame, and I can slide it forward. I'll have to this side. That would be much easier if I grabbed the right sized hex key for the bolts that I'm trying to adjust. All right, those are loosened, so now I can move the heat bed forward just so slightly, so that it doesn't impact the back roller. And retighten the screws that attach the heat bed mounts to the frame. And I'll jump over to this side, start tightening this heat bed mount up. It's looking okay, but I might have to adjust it a little further away from the roller also. And I'm going to want to adjust these front screws down also. Then we can attach the conveyor belt and then loosen these bed leveling screws up to meet the conveyor belt and help it to lay flat. Okay, this side is looking pretty good. lower than the top of the back roller. Okay, now we can attach the conveyor belt. This is one of our very last steps. Here is our conveyor belt. Open this up. There are two sides to it. One of them is a little bit rougher. One of them is smooth. We want the smooth side facing the direction that we will actually print on. So I kind of lightly fold the conveyor belt like this and then feed it underneath the heat bed. And slide this out of the way. I haven't seen any correlation between the speed of the belt and the temperature of the bed, thankfully. Really, the bed temperature is all about getting the plastic to stick to the conveyor belt. The belt's speed itself is usually very slow because it's the z-axis, so it only moves a tiny little bit at a time. Typically, how I like to attach conveyor belts is I will put it on the heat bed and I'll set it something heavy on top of it, and then I will grab our green tape. This is PET. This is the same thing as the top layer of the conveyor belt, and so it tends to bond to itself very nicely. We're going to need a width of tape equal to the width of the belt. It's looking pretty good. Usually when I ship conveyor belts, I pack them with a few different strips of PET tape for the size of the belt that's ordered. So not with a whole roll of tape, but I have the whole roll of tape, so I'm just cutting it from that. The adhesive on this tape is pressure sensitive, so we need to take a credit card or something to force down on there. Let me grab something. I'll use the flat edge of this little part bin just to press down on the tape so that it adheres nicely. Next, we can pull on this conveyor belt. Get this closed loop belt out of the way. And line up our edges. And what I do now is I trim the excess tape off of these edges so that the tape is only on the top of the conveyor belt. And we are almost wrapped up with this build. So if you guys have any other questions, comments, etc., feel free to throw them in the chat. Happy to answer everything. I'm definitely worn out. I feel like I'm gonna lose my voice for the rest of the week. um, Thank you all so much for sticking with me for this huge build. I'm again still super impressed with my own estimates of what it takes me to build one of these, because we are just about at the 5-hour mark. Don't know if I'm gonna test print. Um, Having some of the challenges with the LCD screen and with the is discouraging for me. I almost want to do some more troubleshooting before I do a test print. I also don't have any filament down here with me, but see how long it takes to do these last few steps, and maybe I'll give it a shot. So to tension the conveyor belt, this is a really important step. All we're going to do is we're going to pull on these front roller mounts. Okay, and we're going to do one for the left side, one for the right side. And that's going to apply tension to the conveyor belt so that it will lay nice and flat. And then as we're holding it in place, we're going to tighten the M5 screws to keep it where it needs to be. This is another one of those situations where propping up the front of the printer, super helpful. There are 2 M5 screws that hold these roller mounts in place. I'm worried that we might have lost one of the T-slot nuts that attaches to this roller. So let's loosen it and see if we can reattach, realign. That's absolutely what happened. I loosened this M5 screw too much so that it lost contact with the T-slot nut. I believe we've made contact again. I'm just going to tighten up this screw to confirm. There we go. Now the T-slot nut is engaged again. Now we can tighten the side of the conveyor belt for real this time. And now we'll do this other side. Sometimes I like to take off the conveyor belt axis Z motor when I'm tightening the conveyor belt. It just gets easier to pull Now we can reattach our Z motor. You can see it's nice and flat. Take our pulley, put it around. Looks like we might have had a couple new people join right at the end of the stream. It has been quite a process, 4 hours, almost 5. We're just wrapping up. The whole goal of the Tinybelt project is to be minimalistic, to become the Ender 3 of conveyor belt 3D printers, something that is accessible, something that people can actually afford, to get their first introduction to conveyor belt 3D printing. My first 3D printer was an acrylic frame i3 style printer that showed up as a box of parts with very few instructions, no support whatsoever from the company that made it. I just bought it off of AliExpress. But man, I had so much fun building that printer and eventually selling parts out of my apartment while I was in school. And if the printer was $2,000, I never would have been able to afford it, right? So I have a soft spot for inexpensive printers that can get people running quickly. So, here is where we are at. This is the full assembly. What I'd like to do, I don't think I'm going to do a test print today. I'm ready to wrap up, but I do want to connect to the computer, make sure that things can heat up, cool down, and heat up, cool down, and move the way that we need it to. So, gotta plug in the USB, and I have to grab the power cable for the printer again. Okay, we are powered on. We are connected through Repetier host. We can move Y. We can move X. We can home X, hopefully. Z is still going the wrong direction, so I'm going to have to sort that out offline. I'm not sure. Not sure that's going to be fun necessarily. I might have to do a firmware change. So it can home, cooling fan on. The heatsink fan is doing well. Heat bed. Heat bed is rising, so that's working. All right. So the next steps for this, like I said, they're pretty tedious. I don't want to do them all on stream, but there are videos on how to do it on the channel. So I have a full calibration video. All of the steps per millimeter settings are pretty close. Really, the biggest variable here is the conveyor belt axis, the Z axis. Because I make all of the Formula 32 conveyor belts by hand, the thickness can vary, and because of that, that can alter the Z steps just a little bit. So calibrating your Z axis, conveyor belt axis, super important. when you finish your build. Um, in that video on the channel, there's a link to things with a whole bunch of calibration models that I've made specific for calibrating conveyor belt 3D printers instead of a lot of the conventional printers that are out there. Um, so yeah, the bed is heating up. We're at a 30 degrees C. Let's see if the extruder will heat up for us. And yeah, I'll just jog some of these axes to confirm that everything's working the way that we expect it to. The conveyor belt does move, but it's in the wrong direction. Uh, Excellent point. That sometimes I can flip the electrical connector. Um, Justin, thanks for joining. Not sure how long you've been on the stream, but yeah, you did just build one of these, just as another one of our beta testers. Tons of good feedback coming from him and the rest of the group so far. Hot end is heating up. I set it to 150. I can turn the cooling fan off and on. Still bummed about the LCD screen. Like I said, I'm gonna have to do some troubleshooting on this. Um, with that, we are just closing in on the 5 hour mark. Thank you all so much for joining. I would invite you again, if you haven't already, to subscribe to the channel. I do have more videos planned coming up. Um, and yeah, we're about to sign off for today. There is a belt break in G code that Justin is referring to. I'm disappointed that it isn't flat. It's been working well on my end. I am working on some different formulations. You may have to run it a few times, or just start with some small prints on the edges where, as I've made more and more of these conveyor belts, I'm discovering new things that will help make sure the conveyor belts install more easily. Thank you to everyone who joined, especially to everyone who has been with us all 5 hours. I hope all enjoy the rest of your day. If you have any more questions on the Tiny Belt project, check out the description of this video, where you can uh, click on a link to learn more about the Tiny Belt, look over the specs, sign up for email updates. Um, and yeah,